Hi everyone, today we are going to learn about Gibbs free energy. So let's jump right into it. So will a reaction occur? We know that an increase in entropy means a reaction is more likely. Similarly, exothermic reactions are also favored, and the opposite would be true too. A decrease in entropy is less likely to occur, as is endothermic reactions. Those are also unfavorable. But what happens when we kind of mix and match these? Which one wins out, right? If we have more disorder, but it's an endothermic reaction, is that going to be likely? And so to settle this, we need some kind of like tiebreaker, and that's where Gibbs free energy comes in. So Gibbs free energy is the amount of usable energy to do work. It determines spontaneity. A reaction is spontaneous if you get a negative delta G value, and if you get a positive delta G value, then it's not spontaneous. Okay. This means that if it's spontaneous, it'll occur without continuous outside assistance, and if it's non-spontaneous, it'll never occur without assistance. If the delta G value equals 0, then the reaction is simply at equilibrium. So here's the formula. We're going to be looking at delta G equals delta H minus T delta S. So we've done delta H and delta S already. Delta H is usually in kilojoules, whereas delta S is written in joules. So because of that, we do have to convert to kilojoules, and the easiest way to do that is simply dividing by 1,000. So here's an example down here. If you've got 452 joules, you want to divide by 1,000 to get 0.452 kilojoules. Okay, and this only applies to your delta S value right here. All right, so the main thing here is I'm going to go through one problem. And so you would use your thermodynamic table of properties to find numbers for delta H and delta S. And then once you get delta S, you do want to convert that to kilojoules. Again, that's dividing by 1,000. And then once you get all these numbers, we've given temperature, then we can plug them all in and solve for delta G. So if we had to find H and S, this could take a while. So luckily these problems, they'll give you at least one of those numbers. Okay, in this case, we are given the temperature, and we're also given delta H. Okay, so the numbers that you see up here are the delta S numbers. So now I just have to solve for delta S, which is going to be my total products. Don't forget the coefficients here. Minus my total reactants. Okay, and I run this through my calculator and I get 592 minus 596. So my delta S ends up being -4 joules per mole Kelvin. But again, I don't want a answer in joules. I want to change that to kilojoules. Right? I'm trying to match the units here. So I'm going to change this by dividing by 1,000 to get this answer, -0.004 kilojoules per mole Kelvin. Okay, so using that, I can now plug into this equation. I've got all the numbers I need to plug into it, including this S value. So let's go ahead and rewrite this equation and we'll plug in the numbers. So I'm going to scroll down a little. And so if I plug in the numbers, I'm going to get, let's see, -802.7 minus the temperature is 298 times negative 0.004. So here I'm minusing a negative number. I believe this is 1.192. So I'm going to add those two numbers together, and I get, so this becomes plus negative 801.5, and the units are kilojoules per mole. Okay. So then we want to ask ourselves, well, what does this tell us about a reaction? So remember, a negative value tells us this is spontaneous. Okay. We can also look at the S value, right? So the S value was negative. So what this tells us is that there is a decrease in entropy or disorder. And then lastly, the delta H, because it is this negative number here, that tells me that this is exothermic. Okay, a lot of math, a lot of different steps here, but if you just go through it step by step, I think you can do it. So yeah, just follow these steps here. You want to find delta H or delta S. So if they give you S, you want to solve for H, and if they give you H, you want to solve for S. Generally, you do want to convert S to kilojoules by dividing by 1,000. All of them except for number 2, you need to do that step. And then plug everything in to solve for delta G. Make sure to state if it's spontaneous or non-spontaneous. So the delta G will tell you that. Let's use black here. Okay, delta H tells you exo or endothermic, and then delta S will tell you about the entropy or disorder. All right, that's Gibbs free energy. I hope this helps you complete the worksheet, and this will show up on your exam.